Today, in this session, we are going to talk about predictive analysis of storage health and performance for heterogeneous environment. Myself, Najmuddin, I am working as an architect in Huawei Technologies. I am also a maintainer of Soda Foundation, which is a Linux Foundation sub-project for data management projects. Sulin, you want to introduce yourself?
Hello, everyone. This is Srini. I am also working on the Huawei Technologies of Indian company. My domain in major job is about the Huawei storage management. So I'm also an open source guy to work the Solar Foundation. I'm interested in the storage management.
Yes. So in today's session, we both just try to cover a use case, which is how we can use telemetry and anomaly detection for a predictive analysis. In between the session, if you have any doubts or questions, you can post the questions into Slack. We will be answering in Slack. So the agenda for this session today is we will just see a glance to modern data center. We will see how telemetry is important on infrastructure. We will also see a open source project which is mainly targeted for infrastructure monitoring and alerting. And then we will see how this telemetry data can be used for predictive analysis using some machine learning. Overall, this session, we will be using some of the projects which we used as a POC for this concept to prove. Okay? That is the Soda Foundation project, and we will be just talking about some Soda Foundation project. So over to Sulin to talk about the modern data center and challenges in modern data center.
Okay, and today, many companies has their own data centers, which includes this many devices such as the switches and the storages or servers. But how to manage these devices is becoming critical. The different storage or servers and switches always confuse the administrator, who want to improve the effective of data center management. When the administrator manage the data center, they always encounter many problems. There are many pain points when they manage the data centers, such as the storages or switches or servers have different technologies. The administrator must learning this technology to manage the data center, such as the storages has the storage tools. The different vendors have their own technologies. Here, sometimes the administrator want to switch different technology in case of they can manage the data center smoothly. The second is the resource utilization. The administrator always want to know the whole data center capacity usages. Once the capacity is not enough, he will extend the capacity and buy the new storages or buy the new disks. But sometimes the administrators don't know the whole diagram or the whole capacity usage. So It always confuses the administrators. The next is no recycling of resources. In the data center, there are many, there are thousands of business applications. Sometimes some application will be recycled or released, but the storage resource is still there. So the administrator will should release the storage resource, but he doesn't know when to release it. The next is the force detect. Sometimes the devices always report the issue, but the administrator sometimes the system reports some issue. This issue is not easy to resolve. For the for administrator, he must detect whether the issue is and face that issue. The problem is the administrator sometimes doesn't know where the defect is and how to fix it. Okay, can we go to the next? This is 5 mature model which comes from the Gartner. So it defines which maturity the data center are in. So the basic level is the mature just monitoring system, just reports the health status and the capacity and the environment health. And secondly, is reactive. There this adjustments according to the demand. So the system may will help the administrator handle some issues. And the third level is proactive. So most of company may be in this level. So the manager can monitor the data center status and report some risk and reduce some risk itself. And the therefore is optimizing phase. So it will help the administrator to improve the system and such as they can predict the capacity usage in the future and the status predict the status and optimize itself in real time. And the layer 5 is self-optimizing automatically. That means the system can monitoring and optimize these devices itself. There is no human to handle it. So that's why a data center need a good monitoring system to handle it. So can we go to the next slide? Okay, so this is just about our storage resource. I think the other resource like the switch or computers has the same issue. So for storage resource, it can certify or this a good telemetry tool can optimize or simplify the storage infrastructures.
Currently, the vendors have their own monitoring tool and software for visualizing and analyzing.
They also have different metrics
to the user, such as capacity and performance metrics,
or some other. So if the administrator want to match
all of them, he needs to study
the technologies of vendors. So it will increase the cost of administrators. So so we need a
unified telemetry way to help the administrator
to simplify the
data center management.
But
for telemetry, as the data center, the data is
important.
That's why we found a way so the data collection
is a start.
In our community, our Soda Foundation, we want to do the start step and help the administrator connect the data from the
storage side.
This is our architecture of Soda for
storage infrastructure
management.
From this diagram, you can see
our
SM has
interface. Its REST API. It's expose
the configuration API
and the Crab API.
The configuration will help administrator to discover storage and
configure the storage.
The query interface will
help administrator find the metadata
of the storages,
such as the storage device information and the storage pool and the storage volumes
and so forth. We use Redis
as a distributed node to help us to manage the distributed task.
Once the
administrator registers storages, the backend will, the task manager will
start the resource task to collect data from
the storage side. Currently, we support this the basic storage information and connection and the capacity of storage connection. And the storage pool volume and the disk
are also included.
Our system can be integrated with
the Quant
system, so the Quant can
trigger our
task manager to start the periodic task
to get the storage resource information.
Another feature of our system is alert manager. We use PySMP to start SMP traps
receiver to get the dynamic.
This
then the user will the administrator can get
the alert from our system. He doesn't have to
go through
the different storage and
manager. They just
go to our system. The system will report all dynamic code to their system. We also have our own DB. So all the static metadata will be installed on our DB.
It's a
basic.
It's a basic.
So when we connect the performance, the metrics will be related to our metadata
of storages. Then we can use our
exporter mechanism to push our data to different monitoring platforms,
such as
here, Prometheus platform or Alert
Manager. It's
the exporter interface can be extensible, can
support the developer to push the data
to any
third platform. We are focusing connection for
in storages. In the future, we will extend our mission.
We will connect the data of
switches or servers
or others.
Right. So, as Sulin was explaining, today's infrastructure is moving towards a journey of proactive to optimizing to self-optimizing infrastructure, right? So the need of the hour is a self-optimizing infrastructure. To achieve that, what we need is we need to analyze the infrastructure metrics and take some decisions, right? So machine learning nowadays it is fortunately we have a lot of improvements in machine learning. What is anomaly detection? Anomaly detection is a technique used to identify unusual patterns that do not conform to expected behavior. Right? There are different categories of anomalies: point anomalies, contextual anomalies, collective anomalies, and all. So in the last few years, we have seen significant improvement in predictive analysis. There are challenges around monitoring and managing predictive events uniformly in an IT infrastructure. Right? So, Soda Foundation is an open source project under Linux Foundation. It is an ecosystem for open source data management and storage software for autonomy. Right? Soda Foundation has multiple projects for data and storage management. One of that project, as Sulin explained, is for storage infrastructure monitoring and alerting. And there is another project for anomaly detection. So anomaly detection is a reference implementation of intelligent monitoring, which can utilize the telemetry data through exporters. So the exporters which Sulin was explaining in Delphin architecture, these exporters can be connected to Kafka and use some standard machine learning algorithm, right? So in this session, we will just see how this telemetry data can be connected to anomaly detection module and detect some anomalies. So some of the storage performance metrics which are highly critical for the storage administrator to see are IOPS, bandwidth, latency, CPU usage, queue length, all these things, right? So there can be some custom metrics also. So these metrics can be collected across different resources, volumes, pools, disk, controller, etc. And this can be collected from heterogeneous platform. It can be a directed attached storage like LVM, SAFE, etc. Right? It can be a software-defined storage like OpenEBS and all. It can be enterprise software like LEMC or NetApp or HP, right? Or it can be cloud storage. So we are moving towards a journey like a heterogeneous platform which can connect to any kind of storage backend. So now we are in a position with the direct attached and enterprise software, we are able to collect some metadata from that. And with that metadata, how we can utilize that metadata, right? So there are different algorithms, anomaly detection algorithms available. So these are the two algorithms which we have implemented in our reference project, anomaly detection project. Gaussian is one of that. Gaussian model is a statistical model that assumes the pattern of the data set. A threshold needs to be specified to differentiate between normal and abnormal data points. The example graph you see in this screen is generated using a POC setup where we collected data from LVM. And to generate the data, we used some Linux tools like DD and Boni++ to have some random writes and heavy loads. Right? Another one is DB scan. So DB scan, here also we have used some of the volume level metrics like IOPS, latency, and all. DB scan refers to density-based spatial clustering applications with noise, right? So clustering is used to group similar data instances into clusters. Some of the parameters used are radius and minimum points. So this implementation you can see in our GitHub project. So now I'm going to the actual topic, how we are bringing telemetry and anomaly detection together into one piece. The telemetry controller here is what we are talking about. Talked about is the Delphin or any other telemetry projects, right? Which can generate data in a key value pair, right? A metric is a time having a timestamp and a value. Right? So this metrics can be generated, and this metrics can be pushed to anomaly detection module. So if you see the anomaly detection module, the overall idea is there will be a data generator which continuously or periodically schedule some job to collect the metrics. This request comes to the telemetry controller, and then there we collect the metric, and the collected metrics is pushed to data parser through a Kafka PubSub mechanism, right? The collected metrics are pushed to data parser, and there are different services. One is a prediction service and one is a training service. The metrics will be stored in a database, and the training service will use this metrics to create a model. Okay? So the training service will be run on a huge data set, like millions of data will be collected to create a model. And once the model is created, the prediction service can be run online when we collect the metrics, right? So the prediction service, as of now, we have implemented some algorithm to detect anomalies. One is Gaussian and one is DB scan. A user can set some threshold where he wants to differentiate anomaly with the normal distributions, right? So, and then when the prediction service is run, when the anomaly is detected, this anomaly can be fed as an output to the user, and user can use it, and this can be sent as an alert again back to telemetry controller, and from there an alert will be generated to the user. So this is the project we just wanted to introduce here, and this is available in Soda Foundation project, and This is an open source project. An ecosystem is there with the good community. Everybody is welcome to contribute to this project. So we are from this project, so we just wanted to introduce this uh, uh, in the context of predictive analysis for storage performance on heterogeneous platforms. Right. That's it for today's session. You can give any feedback on our session, and thanks for joining.